write the products of the following reaction, and the reaction related information is given by, this is vinyl methyl cyclopentane on reaction with acid, that is H3O plus acidic conditions, followed by heating. You are asked to write the corresponding product. This reaction is quite an interesting reaction. From the early discussions of whatever examples we made the discussion in the same manner, this particular part of the starting material is electron rich, so therefore the double bond is electron rich, whereas our H3O plus is having H plus, so H plus is electron deficient. This particular portion, that is H plus, is acting as electrophile. Electrophile requires electrons, hence the electrophile initiate the reaction. So therefore if we go for the reaction, our starting material on reaction with H plus, whatever the pi bond is there, this pi bond donates its electron density. See how nice the reaction is occurring. There are two chances. This is primary carbon and this one becomes what? Secondary carbon. Out of these two, one of them is primary, one of them is secondary. Secondary carbocation is found to be relatively more stable compared to the primary carbocation. So therefore here what happens is, it participates in such a addition that H plus is connected to the terminal primary carbon, thus it will generate corresponding secondary carbocation. Whereas this secondary carbocation, now there is a chance for it to undergo the rearrangement type of reactions followed by other reactions. Here there are two chances for the carbocation to do participates in the rearrangement. One with respect to the methyl shift, one with respect to the ring expansion by cleaving this particular or this particular sigma bond, followed by connecting to the secondary carbon. Whereas in these particular cases, generally cyclopentane is stable. It is not necessary for it to convert to 6-membered ring system, but in this case, if it is converted as 6-membered ring system, what happens is this secondary carbocation is transferred as tertiary carbocation. Due to that reason, let us expect that this sigma bond is moved towards the secondary carbocation as carbene ion from here. So therefore it is converted as a 6-membered ring system. Now it is converted as a 6-membered ring system having methyl over here, followed by another methyl is also, methyl is present over here. This is having methyl connected with methyl, followed by another one methyl is present over here. Now here it is having what? Positive in charge. Now here it is having positive in charge. If I provide numbering for its easy understanding, let us fill it as 1, let's fill it as 2, let us fill it as 1, 2, let us fill it as 3, 4, 5, followed by 6, followed by here 7 carbon atoms over here. This is our 1, this is our 2, this 2 is connected with 3, 3 is connected implies this methyl is having positive charge, so therefore this will become 3, this is 3 implies this will be 4, this will be 5, this will be 6, followed by this will be 7. Whereas after getting to this particular stabilized carbocation, now heating affects this particular system and makes the system as more stable by eliminating proton from the adjacent position. That should happen in such a way that it should result the stablest system, that is edge of product should be formed. So therefore from here H plus elimination takes place, thus carbene ion is generated. This carbocation and carbene ion, both combination results into formation of 1,2 dimethyl cyclohexene system formation occurs. 1,2 dimethyl cyclohexene system formation occurs.